Hey guys, so today we are doing 2-5, solving equations involving absolute value. If it's something that you don't understand or you need a little bit more time to write, just press pause on the video so that you can kind of rewind and work at your own pace. So an absolute value expression. So we talked about absolute values about 2 weeks ago, just solving regular absolute value problems where we talked about the distance, and if it was an absolute value of -5, the answer would be 5, where it's always positive. So now we're looking at expressions and equations. So an absolute value expression says it defines an upper and lower range in which a value must lie. So it defines an upper and lower range in which a value must lie. Defines an upper and lower range in which a value must lie. Okay, let's look at an example. So here we have the absolute value of m plus 6 minus 14 if m is 4. So we're just using the substitution property and just plugging that in. So the new equation will be a positive 4 plus 6 minus 14. 4 plus 6 is what? 10. Hopefully that's what you said. 10 minus 14, the answer is -4. Everybody got that? So that's just an expression. An absolute value equation is the distance between 0 and x. It's the distance between 0 and x. So if I said we had the absolute value of x equals 4. Remember, if it's in the absolute value bars, we can assume that it could be a positive or it could be a negative. So x could actually equal a positive 4 or x could be a -4. So if I was to kind of look at it on a number line, we know that the distance can be anywhere between +4 and -4. Because inside the absolute value, if it's an unknown, we don't know which one it is, because when we take it out, it's going to be positive regardless. So it's the distance between 0 and x. Everybody got that? And so some things that we can consider. Let me just make sure this is on the camera screen that you can see it. Alright, so some things that you should consider is that the x inside the absolute value bars is positive or negative. So we're talking about x alone. X is positive or negative. Or that it's a 0. So x is a positive or a 0 and the x is negative. Not the absolute value of the x, because remember when we take it out of the absolute value bars, it's always going to be positive. So what was that x before we took it out of the absolute value bars? And then when we solve equations, we want to isolate the absolute value on one side of the equation. And when we do some examples, you understand what I'm talking about. We want to isolate the absolute value bars on one side of the equation. Everybody got that? Okay, now let's look at some examples. We're going to solve some equations. It's super easy because you already know how to solve equations. We're just looking at it just in absolute value bars. So here we have the absolute value of f plus 5 equals 17. So when we solve this, we aren't changing any signs inside the absolute value bars. We're just taking it out. So we have f plus 5 equals 17. And when we solve it, we subtract 5 on both sides. And so f is going to equal 12. 17 minus 5 is 12. But here's the key. Remember, when we assume the absolute value of 4 up here, we said the x could either be a positive or the x inside there could be a negative. So when solving absolute value equations, you always have to have 2 equations that you write. So our first one was f plus 5 equals 17 once we took it out of the absolute value bars. And our second equation is going to be f plus 5 equals negative 17. So we have it equal to a positive, and we have our equation equal to a negative. Why? Because remember, the distance between 0 and x is how we solve an absolute value equation. So we're assuming it could be a positive or a negative. So then we solve the second equation. Subtract 5 on both sides. F equals negative 17 minus 5, which is negative 22. So when we write our answer, right here you see where it says graph the solution set. When we write our solution set, we're saying that, and we're using brackets, not parentheses, f can be 12 or f can be negative 22. So f can be 12 or f can be negative 22. Because we don't know what f was inside of there once we pulled it out. So if you need to pause, take a second to understand it. Okay, so this example also tells us that we need to graph the solution set. So then we just come to a number line, and I'm kind of going to skip a lot of numbers because I don't believe in writing a million different numbers. As long as I have 0, which indicates that's my middle, separate my negatives from my positives. And so this solution set would be a positive 12, so I'm going to just come over here and write 10 and 15. And so 12 would be about right there. So there's that answer, and then negative 22 is the other one. So I'm going to come over here and just do negative 20, negative 25, so negative 22 will be right there. And so that's how you graph the solution set. So the distance between f and 5 is negative 22 and 12. Everybody got that? Okay. The absolute value of b minus 1 is equal to negative 3. Well, this kind of answer is one where we would say the answer is a 0 with a slash in it, and we call that an empty set. Take a second to think about it. Why do you think we can't solve that answer? Because here it's saying the absolute value of b minus 1 is equal to negative 3. Remember, absolute value is talking about distance, and distance cannot be a negative. Distance cannot be equal to a negative. In this equation, it was equal to a positive, and in order to find the other part of the solution set, we set it equal to a negative. But that was after we took it out of the absolute value bars. So that's automatically an empty set because distance cannot be equal to negative. And that's our answer. Everybody got that? Okay, example 3 says, the temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. Find the maximum and minimum temperatures. Okay, so when we come and solve that problem, it says that the enclosure for the pet snake should be about 80 degrees Fahrenheit, give or take 5 degrees. So that means it could be 5 degrees more, or it could be 5 degrees less. It just wants us to find the maximum temperature and also the minimum temperature. So when solving this problem, here a number line can be easy to solve this. So I'm going to use a number line. So we're going to draw a number line. And so 80 is the number that we're kind of revolving our problem around. So 80 is the goal. That's how much the tank or whatever's holding the snake should be about 80 degrees. We know it's not going to be an even 80 degrees, so it can be some type of distance in between 80 degrees, 5 units. So that means that I'm going to go this way 5 units, and where is that going to land me at? Hopefully you said 85. Or my distance can be 5 units to the left, and where is that going to land me at? Hopefully you said 75. So the minimum and maximum temperatures of the enclosure that holds a pet snake can be 75 or 85 degrees. So that's the minimum and maximum temperature. Now example 4 is going to have us write an equation. So since we're on this word problem, I'm going to write an equation for example 3 just to make sure, just so I can kind of walk you through the process, and then we'll practice it with example 4 and make sure I'm fully on the screen. Okay, I am. So if I was to kind of write an equation for this problem, we're basically saying the distance between x and 80, right? So when we write our equation, it's going to say the absolute value, because remember we're talking about the distance between x and 80, minus 80 is equal to 5 degrees. Everybody got it? So it said give or take 5 degrees. So that's my first equation. What will my second equation be? Hopefully you're saying the distance between x and 80 is equal to negative 5 degrees. Everybody got it? So my distance that I'm traveling to the left or right is going to always be on the outside of the equal sign. Everybody got it? Okay, so we add 80 to both sides. And so it's saying, oh, I forgot to take it out of the absolute value bars. Let me take it out just so I can do it properly. Okay, so we add 80 to both sides. And 80 plus 5 is 85. On this one, I'm going to take it out of the absolute value bars and set it equal to negative 5. Add 80 to both sides. And x is going to be equal to 80 minus 5 is 75. And so that's how we write an equation for that problem. So keeping that in mind, let's look at example 4. Let me make sure that's in the screen. Okay, example 4 says write an equation involving absolute value for the graph. Write an equation involving absolute value for the graph. So take a second to kind of look at the graph. Hopefully you see that on our graph we have dots that are located at 11 and dots that are located at 19. Right? So the first step to write an equation that's going to involve the absolute value is to basically find a median. So we need to find that midpoint, that middle point in between those two. So if I was to kind of count, I have 1, so I'm starting in my dot. 1, 2, 3, 4, 5, 6, 7, 8 units to get to the next one. So what's half of 8? 4. So if I count 1, 2, 3, 4, that's going to land me at 15. So 15 is our midpoint. So to get from 15 to 19, that's 4 units. And to get from 15 to 11, that's 4 units. Everybody got that? So the distance from 15 to 11 is 4. The distance from 15 to 19 is 4 units. So when we write our equation, we know we're going to have our absolute value bars. We're trying to find the distance between x and what? That midpoint. So x minus 15. And how many units did we travel to the right and the left? 4. So it's going to be equal to 4. And so there's our equation. The absolute value of x minus 15 is equal to 4. And just to check, to show you that it works, let's solve it. So our first equation will be x minus 15 is equal to a positive 4. Second equation would be x minus 15 is equal to a negative 4. So I add 15 to both sides. X equals 15 plus 4, which is 19. This one we add 15 to both sides. And x equals 15 minus 4, which is 11. And is that the same points that were originally on our graph? Yep. So our solution is 11 and 19. And so this is the answer to the problem. That's the equation that we wrote. Got it? Just a quick recap to make sure you fully got it. So to write an equation, we had our two original points, 11 and 19. We had to find a midpoint. So we counted 8 units between the two, divided it in half. So the midpoint was 4 units. So we counted over 4 to 15, count over 4 here. So 15 was our midpoint. So the distance between x and 15 is equal to a positive 4. And then we wrote our two equations and solved. So pause the video and try to solve number 5 on your own. Okay, example 5. What are the solutions to the equation absolute value of 3m minus 7 equals 2? So remember, when you're solving absolute value equations, how many answers will we have? 2 answers. That's why you see 2 answer choices. We always have 2. So we're saying the distance between 3m and 7 is equal to a positive 2. And then remember, the second equation is going to say 3m minus 7 is equal to a negative 2. We add 7 to both sides. 3m equals 7 plus 2 is 9. Divide by 3 on both sides. M equals 3. In the second one, we add 7 to both sides. 3m equals 7 minus 2, which is 5. Divide by 3. M equals, hopefully you said 5 over 3, because remember, we're not turning it into a mixed fraction. We leave our answers as improper fractions, a numerator and denominator. And so that means our answer will be what? D. Got it? Okay, we're going to flip over. And on the back, we're just going to practice a few more problems just to make sure you fully understood it. So we're going to do like 2 examples and then that's it. The rest you can do on your own as practice. Let's look at number 11. So if you remember on the first page on the front, I said the steps to solving the equation were to assume that the x inside of the absolute value bars was positive or 0, or that the x was a negative, right? Then also under that I said when solving absolute value equations, first step is to get the absolute value by itself. So if you look at this problem 11, we have the absolute value of 5x plus 5 equals 45. We cannot solve this equation or set it equal to a negative or positive until the absolute value is by itself. So we need to move this 5 to the other side by subtracting 5 on both sides. Now the absolute value is by itself. Absolute value of 5x is equal to 40. And so now we can set up our 2 equations. So we have 5x equals a positive 40 and then 5x equals a negative 40. So get the absolute value by itself and then solve. I'll go back over here just to show you where I had said that. So right there, remember we have to isolate the absolute value bars on one side of the equation. Got it? Okay, so now we're going to solve it. Divide by 5. X equals 8. Divide by 5. X equals a negative 8. And so we write our answer as a solution set. So the solution is 8 and then negative 8. Okay, let's look at the second equation. So this one's pretty fun because now we have a little division going on. So if you look at this problem, we see we have 3 times the absolute value of negative 8x plus 8 equals 80, right? Okay, so remember we have to get the absolute value by itself. Treat those absolute value bars right now kind of like parentheses, but not really because you can't distribute into an absolute value bar. So the first thing we're going to do is first move the 8, isolate that, bring that to the other side to isolate the absolute value. So we subtract 8 on both sides. And we end up with 3 times the absolute value of negative 8x equals 80 minus 8, which is 72. And then the absolute value bars are still not by itself. So if we kind of treat this like a parentheses, remember that's kind of like multiplication. So the inverse operation of that would be division. So we're going to divide both sides by 3 so that those two cancel. And we bring down the absolute value of negative 8x is equal to 24. Right? Now that our absolute value bars are by itself, we can separate that into 2 equations. So we have the negative 8x is equal to 24. And then what's our second equation? Sorry. Negative 8x is equal to negative 24. So we divide by negative 8 on both sides. And then this one is going to be x is equal to negative 3. And we divide by negative 8 on both sides over here. And x is going to be equal to a positive 3. And I'm just going to put my brackets around that. So my solution set is negative 3 and positive 3. It's a little out of focus. Let me just focus it. Okay, give you a chance to copy it down. Okay, pause it and try one on your own. Okay, so now let's look at the next one together. How many of you went to number 13 and said, oh, distance can't be equal to a negative, so the answer is empty set? If you did recognize that, you're slightly on the right track, but you're still wrong. Because remember, if it was by itself, and I'll cover that up, and don't look at my ugly little nails. Don't look at them. If we had the absolute value of negative 2n is equal to negative 75, then it would be an empty set. But right now, the absolute value bars aren't, absolute value bars are not by itself. So we can't mark that an empty set because we don't know yet. So the first thing will be is to let's get that, isolate that absolute value bar, and then we can make the conclusion if it's an empty set or not. So when we isolate, remember we're going to treat that like a parenthesis, so we're not going to distribute, we're not going to bother that right now. Let's move the 5. So subtract 5 on both sides. So we have negative 8 times the absolute value of negative 2n equals negative 75, and negative 5 is going to give us negative 80. Then the absolute value bars are not by itself, so we have to move this negative 8 to that side. It's multiplied, so we have to divide it apart. And now we have the absolute value of negative 2n. I don't know why I tried to make that an m. That's an n. Oops, sorry for the mess up. That's why I shouldn't be writing in pen and math. Negative 8 divided by negative 80 divided by 8 is going to equal to a positive 10. And what do we notice right here? Now we have an absolute value equation equal to a positive 10. So this problem is not an empty set. Just because it was equal to a negative, the absolute value was not by itself, so we couldn't call that yet. So now it's a problem where we actually can solve, and we have negative 2n equals a positive 10. Negative 2n equals a negative 10. Divide by negative 2 on both sides. And n is equal to negative 5. On this one, we divide by negative 2 on both sides. 2 negatives are going to equal a positive 5. So the solution set is a negative 5 and a positive 5. Got that? Questions? If you have questions, just put a star by a problem and I can go over it with you the next day. Okay. Lastly, I'll do one more example with you. We'll look at number 15. So here on 15, we see we have the absolute value of 7p plus 4 divided by 8 equals 3. We have to isolate the absolute value bars first. How do we get rid of fractions? Hopefully you said multiply both sides by the denominator. So we have the absolute value of 7p plus 4 is equal to 24. Okay, now we're going to write both of our equations. 7p plus 4 equals a positive 24, and 7p plus 4 is equal to a negative 24. Subtract 4 on both sides. 7p equals 20. Divide by 7. And I'm going to just write my answer over here. P is equal to 20 over 7. Okay, then we're going to look at our second equation. Subtract 4 on both sides. 7p is equal to negative 28. Divide by 7. And p is equal to negative 3. No! Oop! Sorry. Don't talk about me. Negative 4. There we go. So p is equal to 20 over 7. I'm just focusing. And p is equal to negative 8. So our solution set is 20 over 7 and negative 4. Everybody got that? Here's your homework for tonight. You're doing the 2-5 practice problems. You're doing all of the evens. Wait, 2, 3, 4, 5, 6. Well, you need 10 problems. So let's do all the evens. Do both of the equations, so 5 and 7. 1, 2, 3, 4, 5, 6, 7, 8 problems. Yeah, so we'll do all the evens. 2 through 14 even, and then 5 and 7. Everybody got it? So 2, 4, 5, 6, 7, 8, 10, 12, and 14. Got it? All the evens and add 5 and 7. Thank you.